Hi everyone, welcome to my channel. My name is Rani, and today we're going to talk about decision tree. It's a fascinating algorithm and it belongs to both classification and regression tasks. And this video is among another course or playlist called 100 Days of Data Science. So don't forget to subscribe, like, comment, and share, and let's get into it. What I will cover in this video is the definition of decision tree, main characteristics of decision tree or DT for short, when to use the algorithm and when it has limited performance, then how to design a decision tree, follow up by decision tree most common interview questions, and I will add another video later on about the practical case credit card approval prediction where I implement decision tree algorithm with the evaluation matrix and all these details. Let's start with decision tree. As a definition, it's a white box algorithm used as both classifier and regressor predictor, encodes as a series of if-then-else loop. Decision trees are simple to compute and relatively easy to visualize and interpret. They don't require much of scaling or transforming dataset features, and they can approximate any nonlinear relationship because they can consider separately single parts of their distribution. In classification, we typically use decision trees as to seek to find the best combination of features and instances that splits the data into subsets with a typical homogeneous target. On the other side, in regression, we use decision trees as split the data into subset as well, but with core idea, which is to minimize the mean squared error. We typically have three characteristics linked to decision tree. We start with the entropy, measures the level of uncertainty or randomness in a data set. Lower entropy means higher purity. The less, the merrier. Then we have information gain. When it comes to information gain, measures the reduction in entropy achieved by a specific split. This metric is what the greedy algorithm comes in, that evaluates to choose the best local split, the one yielding the highest information gain. And finally, the Gini index or Gini impurity, which is typically measures how often a randomly chosen element from a node would be incorrectly labeled based on the class distribution. Like entropy, it evaluates local node purity rather than overall tree performance. And when it comes to the scheme of decision tree, like to visualize it, this one with the first we focus on the root node. Then we have on the left side, we have the true, and the right side, we have the false element. So leaf node is the one that doesn't split any further. And when it comes to on the left side, we have decision tree, and we have another two leaf nodes. Okay, that's how we visualize the decision tree. And we also can do this using Python as well. How to design decision tree. So typically I have proposed this example. So simple to understand. So we start with the root node. Does it live in water? If that's true, then it's marine invertebrate. If it's false, then we go to another argument. Does it fly? True, it's a bird. False, it's an animal. Then we have another criteria. Is it a mammal? If that's true, it's an animal. If it's false, then it is insect. This is how to design decision tree. When to use decision tree. So decision tree requires minimum of data processing or feature scaling. Also, it is tolerant with missing values. With that mean we can replace any values with unknown and the algorithm will typically understand. Decision trees are able to mitigate the overfitted by highlighting the number of splits, then establishing the minimum and the max arguments that we are seeing in sklearn library to ensure the model is well regularized. Decision tree is also a white box algorithm, meaning it's interpretable. What happens inside the algorithm itself can be tracked and evaluated. When it comes to the limited performance, there are several of them. Decision tree is greedy algorithm, usually repeats the split seeking reasonable good predictions with proper performance, but it can't achieve the optimal solution here. And decision tree is sensitive as each split is one level directly dependent on the higher level. That leads to become more sensitive or more variance to any minor variations or modification that happen during training the data. We usually upgrade into model random forest algorithm or any solid ensemble tree algorithm such as cat post or XG post, etc. Another limited point is that decision tree is designed for binary splits, meaning splitting every node into exactly two branches, left and right, even for categorical variables with multiple categories. But if you want to seek further than binary classification, we have ID3 algorithm. If you want more info about this algorithm, I can make a short video about it. So let me know in the comment below. And finally, with the last limited point is that in the case of very small data sets, decision trees can easily overfit if they are permitted to go deeper. We tend to memorize the noise present in these limited datasets. When applying a decision tree to a small dataset, it's essential to implement strong regularization through hyperparameter constraints, such as max depth, mini-sample split, or mini-samples leaf, etc., or even to prune the tree afterward. But for small datasets, simpler linear models or regularized ensembles algorithms frequently yield better performance than unconstrained trees. And with the final slide in this video, the data decision trees interview questions. I forgot to replace this one with decision trees. Okay, so what is the Gini index and how is it used in decision trees? Second question, what are entropy and information gain in decision trees? Third question, explain how missing values are handled by decision trees. Then we have if decision tree is overfitting, how would you mitigate it? Is decreasing max depth is a good idea? And another good question, explain the card algorithm for decision trees. Finally, we have what is the tree posting in decision trees? And in case you have a decision tree with a low bias and high variance, how to ensure that the model has low variance. That's it for today. Thank you so much. If you find my content useful, don't forget to subscribe, like, comment, and share. And I see you in the next video. Bye.